All right. So just a reminder on how to do a basic 2x2 determinant. Remember, we do this times this, A times D, minus C times B, or B times C, whichever way you go. Okay? So for this one, remember we do this times this, minus this times this, which is 15, equals negative 12, and then you guys would solve, right? We don't need a review of that, do we? So that's just like a 2x2 determinant, right? We call this a 2x2 matrix or determinant. So now for the new stuff. What if we have a 3x3 matrix? There are so many ways to solve these, but this is the one way we're going to learn starting today. I don't know if we'll learn different ways yet because I haven't ever finished this book, but this is the first way you're going to learn how to do it. So we're going to rewrite this column right here. Everybody rewrite it. 1, 0, 5. And then I'm going to rewrite the middle column right next to it. 2, 4, negative 2. And you want to write pretty neat and like line your numbers up and stuff, or else it kind of gets confusing. So what we do is we're going to multiply going down. So I'm going to get a little highlighter out. Maybe. So I'm going to do this guy right here. I'm going to multiply those three numbers. Oh, it straightened it out. That was so cool. And then I'm going to multiply these three numbers together. Oh, boom. And then I'm going to multiply these three numbers together. All right? So just like when we did determinants before, right? With the 2x2, we did like this times this minus this times this. Only now we have 3 rows. So I'm going to do this times this times this plus this times this times this plus this times this times this minus this times this times this plus this times this times this plus this times this. Yeah, I know, right? So here we go. Whoa, whoa. I know, a little too fast. Don't worry, let's actually do it. All right, so first I'm going to do 1 times 4 times 3. So everybody with me, what's 1 times 4 times 3? 12. So you don't have to write out that part. I should see a total of 6 numbers, okay? Now I'm going to do 2 times negative 1 times 5. So everybody with me, 2 times negative 1 times 5 is negative 10. And we are adding these together. All right, so I'm adding a negative there. And then I have negative 3 times 0 times negative 2. 0. All right, perfect. And then we need to remember, just like when I do a 2x2 determinant and I multiply and then I subtract and multiply the other way, we now subtract. Okay? And now I'm going to go the other way, and I should have 3 numbers in parentheses that I add together. So now I'm going to go this way, and I'm going to multiply going this direction. So what's 5 times 4 times negative 3? Negative 60. And then I'm going to do these 3 numbers right here, and don't get off or you'll get messed up. Negative 2 times negative 1 times 1. What's that? And it's always adding. If you're adding a negative, that's fine. So I'm adding 2 because negative 2 times negative 1 is 2 times 1 is 2. Plus, now I'm going to multiply these 3 together. 3 times 0 times 2. You got to love when there's a 0. It just makes it a lot easier. All right? Now I'm going to add these together. So this is the ones going this way. I take the sum of all those multiples, and I get 2. And then I'm going to add these going this direction, and that would be a negative 58. Right? That was, we got in parentheses. But I still have this negative, so it ends up being 2 plus 58. And we get 60. Okay? And that is the determinant of the 3x3 matrix. What? All right, let's try this one. Okay, so now we've got Kramer's rule with a 3x3. So just like in a 2x2, it's very similar. So let's say I want to solve for x. If I want to solve for x, we're going to write the determinant on the top that will help us find x. We always take these 3 numbers that are the answer side and we put them in the x column. So I'm going to replace this first column with 7, negative 2, 16. And then we rewrite the same y coefficients down the middle. So my y coefficients are 1, 1, and negative 1. So right here I'm going to do 1, 1, and negative 1. Then I rewrite my z coefficients. My z coefficients are 2, negative 1, and 2. And just like in the 2 by 2, we divide then by the original matrix. So in the denominator of this, we do another determinant. And in this one, we still have the same y's, right? This guy's the same. I have the same z column, but we do our original x's right here. So I've got a 2, a 1, and a 3. All right, so I'm finding the determinant with this guy substituted in for x of the top, and then the determinant of the original left-hand side. So I got to rewrite my first two columns. So I have a 7, a negative 2, and a 16. And then I have a 1, and a negative 1. All right, always start going down, right? So I'm going to get a little highlighter out so I can see what I'm doing, and I want to multiply this times this times this. Again, so I do need to see what that number actually is. So 7 times 1 times 2 gives me 14. And then I add. And now I'm going to find that next little diagonal of 1 times negative 1 times 16. So 1 times negative 1 times 16 is negative 16. So I'm adding negative 16. Plus, now I'm going to go down the next one. 2 times negative 2 times negative 1. And that is a positive 4. Wow, I just wrote in highlighter. Woo! All right. And then you got to remember we subtract going the other direction. So let's see if I can get a different color highlighter now. I'm going to go this way. 16 times 1 times 2. What do we get for that? Yep, 32. Yep. All right, and then I'm going to do negative 1 times negative 1 times 7. So that's plus 7. And then I'm going to do 2 times negative 2 times 1. So this one gives me plus negative 4. So I should always see those 6 numbers, and that's how I know what I'm checking. So now I've got 14 minus 16 is negative 2 plus 4, which is 2. And over here I've got 32 plus 7 is 39 minus 4, which is 35. And 2 minus 35 is negative 33. That is just the numerator right there, right? I know. So like this whole determinant of just the top is negative 33. So now I have to do the same thing with the bottom part. So I'm going to go ahead and rewrite the first two columns. So I have 2, 1, 3, 1, 1, negative 1. All right, here we go. We'll try to go a little faster. So I'm going to go down. What's 2 times 1 times 2? 4. Plus. Now I'm going to move to this next number. 1 times negative 1 times 3. Negative 3. Plus 2 times 1 times negative 1. All right, and then do we add or subtract here? Subtract. And now I start going the other direction, going up. What's 3 times 1 times 2? Good. Plus, what's negative 1 times negative 1 times 2? Plus, what's 2 times 1 times 1? Okay. Add these up. I have 1 minus 2, that's negative 1. Add these up, minus 10, which is negative 11. So that's the denominator, all right? So I have negative 33 divided by negative 11. This is what x is equal to. So x is equal to positive 3. Now we have to find y. I will just set it up and we won't solve the whole thing, okay? So just to show you how to find y, we got to do one big 3 by 3 matrix, right? Divided by one big 3 by 3 matrix. And we have z. I'm not going to do all this because that would take forever. But I'm going to show you like what to set up, right? So if I want to find y, I'm going to replace the y column with the answer column. So first I write the x's like normal, 2, 1, and 3. So this would be 2, 1, and 3. And I'm going to change colors just to remind you that we rewrite the y's as 7, negative 2, 16. So my middle one should be 7, negative 2, 16. Was it negative 2? Yeah. Okay. And then the z's stay the same. 1, negative 1, 2. Oh, I should have gone back to red there, but I think you guys got it. All right. So the y's changed. The rest stays the same. And in the denominator, should I redo all of this? Actually, no. Because what did I already find out the denominator's answer is? Yeah, so I would probably just be like, oh, I already know it's negative 11. Right? And then you redo that whole craziness. Same with z. Let's say I set that up. I already know it's over negative 11. I need to find my 3 by 3 matrix. I would keep this guy the same. Yeah.
Can't you just like plug in the other two?
Yeah, that's enough. You could do that too. I probably would do that. All right, but if, say it said just find z, and you didn't have x and y, then make sure you put the answer column in the z column, and the y column would stay the same as what it was originally, which is 1, 1, negative 1. Yeah, ginormous box. Okay, so the only reason that number 2 is on here, what do you guys notice is different about this one than number 1? It's missing some, yeah. So like in this one right here, what's missing? X. So you need to put a 0 in that spot. And on that last one, what's missing? Z. So you need to put a 0. All right? So let's just set up 1. I know, just 1. Let's say I want to find Z. All right, just Z. Maybe the book just asked you to find Z. All right? So if the book asked you to find Z, then Devin, what should I put right here in this X column? Ooh, and that's where people mess up. 3, 0, 1. You got to be really careful because there is no X. So you have to put a 0 there, right? All right, and then column, and what would I put for the Y's right here? Yeah. Yeah. So you do all the Y's. 2, 2, 2. Good. And then Peyton, I got to swap this one out. So what's going to go on the Z's if I'm trying to find the Z's? Exactly. All right, and then in the bottom, we would have 3, 0, 1, 2, 2, 2. But I would need the original Z's. Fabio, what would I plug in right here for my Z's?
1, 0, 0, 1, 3, 0.
1, 3, and then there's not a Z there. So 1, 3, 0. When you have zeros, your life is way easier. All right, these go like so much faster because when you multiply across and you see a 0, just put a 0, okay? Anything times 0 is 0. Okay, determine the system of equations given the expression that would find the value of y and write the expression that would find the value of x. So, like, what is the original problem is what it's asking. So, if I'm finding y, I already know that this is what part of the equation? It's the equals part. I have 3 things, and this has to be the equals part. And then this part right here in the denominator, I know sets up my original equation. So if I was going to write it, this would be 2x minus 3y plus 1z. And this would be 1x plus 1y. If you wanted to put a 0z there, you could, or you could leave it blank. And this would be 4x minus 5y minus 8z. So there's the expression that we're looking for. And then it says after that, find the value of x, right? The expression that would find the value of x. All right, so if I want to find the value of x. Thomas, what goes in this first column? Oh, Tom Steve. Yeah, exactly. All right, and then we'd write our y's, which would be -3, +1, -5. I'm just going down the y's. And then I go down the z's. Don't forget there's a 0 here, so it'd be 1, 0, -8. All over my original matrix, which was right there, and you could rewrite it. Okay? That was a long one. Let's see how long that took.